Welcome to the part 3 of this series. Today we will discuss everything about SNMP based discovery. Okay, let's begin with what is SNMP. As you already know, it stands for Simple Network Management Protocol. Now, what is it used for? Traditionally, it is used for network monitoring and modifying device settings and configuration remotely. It was initially developed for switches and routers, but it has since been expanded to a wide array of other devices such as Windows servers, Linux servers, printers, power supplies, and many more. Moving on, there are two key things that you should know about SNMP. One is OID and the other is MIP. Object identifier is a numeric representation of anything that can be monitored with SNMP. Say you wanted to monitor the host name, then the numeric OID will look like this. This might sound confusing initially, but think of it as an IP address or a zip code for the time being. Next, MIB, Management Information Base. This might sound even more complicated, but MIB is just a text file that allows us to translate a numeric OID to a word-based OID. But still, you might feel only the last word makes sense. What is the meaning of what precedes? Let me simplify that for you. There are two types of OIDs, standard and private. Standard OIDs are a set of predefined OIDs that needs to be implemented by default in any SNMP implementation. Private OIDs are custom or special implementation of SNMP. Depending on the nature of the device in context, there might be need to monitor specific details about the device. So we have to collect the details about custom OIDs and MIBs for configuration item that we wanted to discover. Often you will find these details in the manufacturer's portal. Now back to standard OIDs. Here is a general OID hierarchy, and please note the OID system object ID, which is a key OID that ServiceNow uses for classification. Now, this is how OIDs are translated to MIBs. As we are here, let's look at private OID in detail. Private MIB has enterprises and then the manufacturer underneath in the hierarchy. You might be wondering why 3375. Enterprise number is allocated by Internet Assigned Numbers Authority. In our case, BIGIPF5 has the number allocated by INA. Remember we discussed about system object ID OID? The value of that OID will be a private OID indicating the manufacturer and the details about the device in context. In our case, you can see that it's translated to Big IP Virtual Edition from F5. Now let's talk about SNMP versions. There are three versions, 1, 2C, and 3. For our purpose, V3 is more secure than the other two. That is, while 1 and 2C has no username but just a community string as a special password, while V3 do not have community string but username and password. Additionally, V3 supports encryption. Here is how SNMP works. SNMP agent runs the SNMP service that listens for any request on a given port. The default SNMP port is UDP 161. Now, SNMP server initiates requests to the client specifying the OID/MIBs that are of interest, to which SNMP client responds with the values of those OIDs. Now, this type of transaction is known as SNMP polling. There is another type of transaction where the agent initiates the conversation by notifying the server that some event has happened in the agent. Now, this is known as SNMP trap. Now, on the server, there should be a listener running to receive these notifications. While SNMP polling is used in ServiceNow Discovery, SNMP trap is used in event management. Now that we know the details about SNMP, let's focus on how SNMP-based discovery works in ServiceNow. In the scanning phase, discovery starts with Shasham probe. Now, this usually contains a list of protocols and ports that needs to be scanned against the CI, say SSH, HTTP, WMI, SNMP, etc. Upon receiving this, mid server try to connect to the remote CI to check the port status and generate an input message with port status and sends back to the ServiceNow instance. Now, on the ServiceNow instance, Shasham sensor processes this to determine which classifier prop to be initiated next. In our case, SNMP classify. In the classification phase, a SNMP classify prop output message is created with a list of MIPS which are required for classification. Mid-server worker translate this into SNMP GET, SNMP NEXT GET, or bulk request to the CI. The SNMP agent slash client running on the CI process this request and provides the data for the requested OIT that is sent back to the ServiceNow instance where the classifier sensor process this response. As part of this process, the system object ID OID value is checked in the SNMP system OID table and any matching criteria in the classifier probe. If it finds any match, then the associated probe is triggered for identification and exploration phase. And finally, in the identification and exploration phase, the corresponding horizontal discovery prop pattern output message is created for mid-server to work on. This pattern contains a list of steps for identification and any extensions for further details. Now, mid-server executes these steps, and upon completion of all the steps, the result input message is sent back to the ServiceNow instance, and the pattern processor then processes this response and creates CIs, relations, and references for the configuration item in the CMDB database. Let me show you the credential table first. And I don't have any SNMP credentials created yet. Let me do a discovery. Let's review the Shasham output message. You can see the protocol and port listed in the output message. Let's review the response. You can see the port status as open. Since we don't have any credentials added, the discovery could not be proceeded. You can see the same in the discovery logs. Let's create the credential and try the discovery once again. Now you can see it was able to do the SNMP classify and it got 29 OIDs back from the mid server. So even after getting these 29 OIDs, it was not able to classify it. Let me show you the OID spec in the request. And let me show you from where these list is populated. Now let me activate the demo classified prop with only one OID and add sensor record to it. We'll run a discovery again to show you the difference now. Now let me show you the mid server log. We will see something special. Even though we had only one OID added, Mid server by default looks for sysobject ID and system uptime before attempting the list of OIDs that we have configured. You can see one OID back here, but still it's not classified yet. Let's look at the reason. Let me flip back the probes and then add the sensors. Now let me get this system object ID and search in SNMP's system OID table. See, you don't find it here. And that's the reason classify failed. Now let me show you how match criteria works. I have created a custom classifier for this demo. This classifier, if criteria matches, will classify the CI as Linux server. Here is the match criteria. Let me update the criteria to match our demo data. And add a prop for identification. And let me run the discovery once again. Now you can see the classification getting successful and moving on to identity phase, and that CI is being classified as the Linux server. Now let me add back the system object ID and rerun the discovery. You can see the associated pattern for identification phase. Let me open it and show you the number of steps on the identification. Finally, let me show you quickly how do we extend the pattern to get missing data. We'll show you how to get OS version in today's demo. With that, we have come to an end of today's demo. Thank you for watching.